we'll try to introduce a matrix notation today. We'll try to define what is a product matrix by vector is, but let's see. I guess I'm switching to the whiteboard. So you recall that the following three things are going to make equivalent. So you have a system of linear equations. System of linear equations. Say A11 x plus A12 x1 x2 plus A1 and m, I guess x m equals to B1. A n1 x1 plus a n2 x2 plus a nm xm equals to en. We have system of linear equations. We can write down corresponding augmented matrix. So augmented. A11, A1m, and so on, AN1, so on, ANM, and B1, BN. Right. So the solution of system of linear equations and solution of our corresponding augmented matrix, they will be good. Instead of writing system of linear equations, what we can do instead is we can write down corresponding vector equation. So corresponding vector equation will look something like this. A11, A n1, x1 plus A12, A n2 x2 plus a1m anm xm equals to vector b1. Yeah. Right. That's what. Now I'll rewrite the whole thing using maybe more like vectors. We'll put a bar and so on and so on. So what I'm planning on doing is, instead of writing this vector, I'm going to write down a1 bar. Okay, so it's a bit hopefully clear. So instead of this one, I'm going to write an a2 bar. And this one, am bar. And this one is b bar. And instead of writing this augmented matrix, corresponding augmented matrix is going to look something like a1 bar, a2 bar, and so on till we hit am bar. And then we, does that make sense? Okay with that notation? So I'll rewrite augmented and vector equation using this notation, using vectors. Like exactly using like more symbolic, a little bit easier to write. That was kind of point of introducing vectors, so notation will be a little bit easier. So if that's okay with you, I'll switch to the next page. Okay. So what we've got so far is a1 x1 plus a m xm equals to b. That is vector equation. And corresponding augmented matrix look like A1, AM, B. Okay, that's augmented matrix. And solution of a vector equation and solution of augmented matrix will be equivalent, right? So we will have exactly the same solutions. So notice that. So they have the same solution. Or they both don't have, both inconsistent. Right? So augmented and vector equation very equivalent. Now what I want to do is I want to introduce matrix notation. So what I will do is I kind of want to combine information from the first line and second line. So what I want to do is the following. I want to write down something like matrix A times vector X equals to B. Here, A will stand for the matrix of coefficients. So all those not augmented, but A1 through AM. Then we multiply it by vector X, and we shall get vector. Okay, so that's what we want to introduce. That's what we want to introduce. Okay. And the way we're going to introduce it is saying this guy, which is this guy, is exactly the same thing as here. Okay. So that's how we introduce it. So we will say, so I guess I will put it on the next page. So what I mean by that is, if A is n by m matrix, and if A equals to A1 through AM, then we define A times B to be A1 AM. Okay. Now you want to be careful. B is going to have n entries. And that is going to be equal to the previous line. M entries. So it's going to be equal to what we had just a second ago. This line, right, on the left side. So it's going to be equal to A1 times B1 plus A2 times second entry plus AM times nth entry. So you have to be careful which are vectors and which are not vectors. That's how we define it. Okay, that's our definition. Example. Find 8, 3 minus 4, 5, 1 minus 1 times 1, 0, 2. Okay. So we have our vectors 8, 5, 3, 1, -4, -1. Okay. So see those columns from the vector, from the matrix. And then first vector, first column has to be multiplied by 1. Second has to be multiplied by 0. Third one multiplied by 2. And they're going to add the result. So what we're going to have is 8, 5 plus 0, 0 plus -8, -2. So we're going to get 8 plus 0 minus 8. 8 plus 0 minus 8. 5 plus 0 minus 2. So we're going to get 0 and 3. Okay. So what we do is from our matrix multiplication, you switch to vectors and finish up. So one more time. 1 is the first entry. It corresponds to the first column. 2 is the second entry, so it will be multiplied by second column. 2 is the third one, so it has to be multiplied by the third. And from here, you also notice that order of a matrix and order of a vector it multiplied by have to have a connection. So for notice if matrix A has, for example, in our case, 3 columns, then vector corresponding vector multiplied by should have 3 rows. So in general, if A has m columns, then to be able multiply A times vector B, dimension of B should be m cross 1. So it should have m columns, m rows. Sorry. So you see this number and that number, they should be equal. So maybe the shortcut notation, I'll put it somewhere here. AB. If M has dimension M times M, B should have dimension M cross 1. The numbers in the middle should be the same. And if you notice it maybe even further, the remaining ones, these ones, and 1, that will be the size of outcome, size of answer, dimension of answer. Okay? One, 2, 3, 4, 5, 6. Okay. I want to take that matrix and I multiply by vector. So that vector should have how many rows? again, the way we want to think about it, we should have something to multiply by the first one column and something needs to be multiplied by second column. And we don't want to have anything left out, so we want to have exactly one for something, one for each column. So how many entries do we need to have? So we're going to have 2, and let's pick 2 numbers, say -1 and 1. Then it's first column multiplied by -1 plus second column multiplied by 1. So we're going to get -1, -3, -5 plus 2, 4, 6. So we're going to get 1, 1, 1. So next, a bit more general example. Here we have matrix A, which is 1, 2, 3, 3 minus 1, 0, 1, 0, 2. We have X, which is going to have 3 entries, X1, X2, X3. Prime A times X. Okay. So it should have 3 entries. So go ahead, do the calculations. I'm going to give you a couple minutes to work on it. So we have 1, 3, 1, 2 minus 1, 0, 3, 0, 2, X1 for the first, X2 for the second, X3 for the third. Add them up. And we're going to get an answer for AX, A times X. X1 plus 2X2 plus 3X3. 3X1 minus X2 plus 0X3, I guess I need to write that. X1, 0X2 plus 2X3. Again, that's exactly what we wanted to have, because if you look at what we started with, matrix A, right? And if you feel that's your left side, that's a matrix of coefficients, right? And you want to relate that to your system of linear equations. And this guy corresponds to the left side before equal signs of your linear equation. So that's exactly what we got here. Right? That's the left side. And then on the right side, you will say equals to B1, B2, B3. Okay? So AX is the left side of your system of linear equations. A is M by N. A equals to then A X equals to B is the same as X1 A1 plus X and AN equals to B. And also is the same as system of linear equations, if augmented matrix A1, AN. Okay, so they all three are equivalent. So